In this section, we have two objectives. First, find the volume of a solid of revolution using the disk method. Second, find the volume of a solid of revolution using the washer method. If a region in the plane is revolved about a line, the resulting solid is a solid of revolution, and the line is called the axis of revolution. The simplest charged solid is a right circular cylinder or disk, which is formed by revolving a rectangle about an axis adjacent to one side of the rectangle. Okay, so look at this rectangle with the height R and the width W, and if this rectangle is revolved about this axis of revolution, and the solid of revolution, or we call a disk, will be formed. And the radius of a disk is the height, is the length of the rectangle. And the width of the disk is the width of the rectangle. To get the volume of this disk, we take the surface, we take the area of this circle, we times width. So that's why we have pi r square is the area of this circle and times width. The volume of such a disk is volume of this equal to the area of this and then times the width of this. So that's why we have pi r square w, where r is the radius of the disk and w is the width. To see how to use the volume of a disk to find the volume of a general solid of revolution, consider a solid of revolution formed by revolving the plane region in figure below. So look at this plane region. So if this plane region is revolved about this horizontal axis, so the solid of revolution will be generated. And if the plane region is revolved at about the horizontal axis, so the vertical rectangle will be used. And look at this vertical rectangle. The height of this rectangle is r. It actually represents the radius of this disk. And the width of the rectangle is delta x. It's also the width of the disk. And the volume of this solid of revolution can be approximated by the several disk volume. To determine the volume of this solid, consider a representative rectangle in the plane region. When this rectangle is revolved about the axis of revolution, it generates a representative disk whose volume is delta V equal to pi r squared times delta x. Schematically, the disk method looks like this. The volume of this is V equal to pi r squared W, and the representative element delta V equal to pi into r xi squared times delta x. And then for the integration formula, the solid of revolution is pi integrate the rx squared with respect to x from a to b. A similar formula can be derived if the axis of revolution is vertical. To find the volume of a solid revolution with this method, use one of the formulas below. If the plane region is revolving about the horizontal axis, so we will use the vertical rectangle. And because of the vertical rectangle has the width is delta x, so we perform the integration with respect to x. And if the region plane is revolved about the vertical axis, so meaning that we will base on the horizontal rectangle, and the width of the horizontal rectangle is delta y. So that is why in integration we integrate with respect to y. Find the volume of the solid formed by revolving the region bounded by the graph of fx equal to radical sine x, and the x-axis from 0 to pi about the x-axis. Look at the solution. From the representative rectangle in the upper graph, you can see that the radius of this solid is equal to the height of this rectangle and is equal to the function fx. So where the fx is equal to radical sine x is given from the equation. So the volume of the solid of revolution is pi times the integration of Rx squared with respect to x from A to B. Where the Rx is a function, is the given function, is a radical sign x. And we simplify this integrand. So we have integrated sine x. We perform the integration and we substitute in the given interval. And we have a volume is 2 pi. This method can be extended to cover solids of revolution with holes by replacing the representative disk with a representative washer. The washer is formed by revolving a rectangle about an axis. Look at this rectangle. The rectangle is above the axis of revolution, so that there exists a gap, and the gap here is from the axis of revolution to the bottom of the rectangle, and this gap we call small r, and the distance from the axis of revolution to the top of the rectangle we say BR. And imagine this rectangle bar is rotated about the axis of revolution, and this with a hole at center will be formed. And this is so-called washer. If small r and big R are the inner and outer radii of the washer, so actually the small r is the radius of hole, and the big R is the radius of the washer, and W is the width of the washer. Then the volume is given by the volume of the whole disk pi r br squared W minus the volume of this hole pi r squared small r squared W. To see how this concept can be used to find the volume of a solid of revolution, consider a region bounded by an outer radius big R and an inner radius small r. So look at this, the plane region. Actually, these plane regions formed by the straight line and the quadratic curve. So the distance from this horizontal axis to the linear line, we say big R, and the distance from this horizontal line to the quadratic curve, we say small r. And imagine this plane region is rotated about the horizontal axis, and the solid of revolution with hole will be generated. If the region is revolved about its axis of revolution, the volume of the resulting solid is given by this washer method. Note that the integral involving the inner radius represents the volume of the hole and is subtracted from the integral involving the outer radius. Look at this example. Find the volume of the solid formed by revolving the region bounded by the graph of y equal to radical x and y equal to x squared about the x-axis. Look at the figure here. So this curve is quadratic function. It's a quadratic curve, and this curve is radical curve. And from this graph, we found that there are 2 points of intersection. So the first point is 0, and the second point is 1. To get the points of intersection, we can equate these two equations, and we solve for x. Then, from our theory, the distance from the this to the top function is a big R, and the distance from the x-axis to the bottom function we call small r. Right? So meaning that the big R is radical function and the small r is quadratic function. And if this plane region is rotated about this axis, so this solid of revolution will be formed. So as I said just now, the outer radii is the big R is a radical function, and the inner radii is the bottom function is a quadratic function, and the interval from 0 to 1 where we equate then we solve for x, we get the points of intersection. So we can apply the washer method. So we substitute the Rx, the big R and the small r. and then the interval as well. So we have this form, and we simplify this integral. So from here we can perform the integration using the power rule. And lastly, we have the volume is 3 pi over 10.